All right, in the first video, the normal model that we used had z-scores that were nice integers. So we were able to use the empirical rule in order to find those probabilities. However, that's usually not the case. Usually we have to find z-scores. We're going to go to 2 decimal places, and it's going to tell you where to find your probabilities. So remember that a z-score of 0 is here at the mean. And if z-scores are positive, we're on the right-hand side of our distribution. If z-scores are negative, then we are on the left-hand side of the distribution. And your z-score tells you your relative placement to the mean based on the number of standard deviations. So if I end up getting a z-score of 1.57, then I know that x value must be right here. If I get a z-score of negative 2.30, then I know that data value must be right here. Now, once you know the z-score, you are able to find the probability of that z-score happening using either the normal model or through technology, and I will show you how to do both of those. So we're going to use our same example that we did with the biology class. So the biology class has scores that are normally distributed with a mean of 75 and a standard deviation of 7.5. All right, the distribution looks the same. Okay, nothing changes. 67.5 is still 1 standard deviation below 60, and then 52.5 would be 3 standard deviations below. 82.5, 90, and then 97.5. So this is what our full grade distribution would look like. I want to know what percent of students made lower than a 70. Well, I see that 70 is somewhere in here, but it's not a z-score of like -2 or anything like that. It's between 67.5 and 75. So I know I'm going to have to calculate what that z-score is. I do that by doing x minus the mean all over the standard deviation. I'm going to use my calculator here. -5 divided by 7.5 gives me -0.67. So that -0.67 tells me I'm not quite 1 standard deviation away from the mean. I'm right here with a score of 70. And I want to know what percent of students made lower than a 70 on the exam. Again, I can't use the empirical rule. I need another way to do this. So one way to do this is using the normal model. In your notes, I have copied for you in the very back the normal model distribution. Now, on this table, it will always give you, if you look at the diagram here, it'll always give you the left-hand side area. And that's what I'm trying to find in my problem here. So notice your z's are here on the ends, okay? And then your p value, your proportion, is in here. So if I go to -0.6 and then over to a hundredths place of 0.7, I see right here that that proportion is 0.2514. Now notice I don't say -0.76 and then equals this. I make these two separate things. This is my z-score. This is my location relative to the mean of where 70 is on my distribution. This right here is the probability that matches this part of my distribution model. Now, the other way you can do this is with technology. So if we go into StatCrunch and go to Stat, Calculators, there is a normal model calculator that you can use. If you keep the mean as 0 and the standard deviation as 1, then the only thing you have to plug in is your z-score because it already has it in standard normal curve, if that makes sense. So you, instead of plugging in your x value, you plug in your z because you are standardized to 0 and 1. And it will find that for you. That's the same value we had in the table. The other thing you can do is you can plug in the situation, mean and standard deviation, and then in context put 70, and it will do the same thing. Now this looks like it's including all the way through. Oh yes, okay, 70, that's okay. It's okay, so you're gonna be off by a little bit, but really we just care that it's 25%. And that's why those are a little bit different there, okay? All right, let's look at 80% or higher. So 80% would have a z-score of positive 0.67. So on this distribution, the same proportion of students made a 70 or lower versus an 80 or higher. And that makes sense because 70 and 80 are the same distance from 75. So this proportion here is also going to be this here. Oh, here's why this is different. This z-score is rounded to use in the table, okay? When we went into StatCrunch, it uses 0.6666667. So this is actually a more exact answer and way to do it. Now, this is one thing I want to show you though. If you go in here and just replace this with 80, you don't get the same answer that we just got. Well, notice that's because here is a less than, and look at your shading. It also, if you go to the table and go to a positive 0.67, so z of positive 0.6 all the way over to 7, you get 7486, or the more exact answer, 7475. Let's just put in our notes here that this probability, I kind of want to change my color. Okay, so this probability is about 75% of the population. So drawing your distribution and making sure that you're choosing the correct side is very, very important. We want or higher, that's going to be this side here. All right, on C, what percent made a C on the exam? So we are going to assume that a C is from a 70% through a 79.9999%. Okay, that really means we can just do this percentage here. Well, I've already found those two z-scores. So I already know if this is 70 right? That was negative 0.67. And if this is 80, oh, that wasn't really symmetric. That's okay though. That's 80. Okay. Now let's just use this kind of in like a truncated numbers, like 75%, 25%. I know that this is 25%. I know that this is 25%. I know that this, including that tail, right, was 75% all the way down. But that's not what I want in this problem. What I want in this problem is this between proportion. Well, if this whole thing, there's a couple ways to think of it. If this whole thing is 75 and I don't want 25% of it, then the probability left over has to be 50%. You could also say, well, if this tail is 25% and this tail is 25%, then the stuff between these two numbers must be the other 50%. Okay. Now, not all of the problems are going to be this nice with regards to numbers, but this is just a really good, solid example for you to have in your toolbox of how to do these types of problems using the z-score, the table, and the and technology. Let me show you one more thing on technology-wise. If you do want to go to between, so it carries over the mean and the standard deviation, you can say that you want between these two, and it will find it for you. Okay, we got 50%, which is perfect. A good rounded percentage there. And if you wanted to do this with a mean of 0 and a standard deviation of 1, then remember you would then use the z-scores for that calculation there to standardize it. That's just basing it based off the z-score calculation, doing 0 and then 1 versus in context here.